Hello and welcome to another tutorial on dev.java website. We are looking at the arrays, which are built-in types in Java, and we said that arrays represent objects, right? Anything in Java that is not a primitive type has to be an object type, which means they already have methods that are included in the object class like hash code, equals, etc. But then the problem is that there is no class definition for arrays. So these are some sort of built-in type into the JVM, and therefore you can never subclass a array type like an int array or something, right? And we said that arrays are static, have a static length. These are static arrays, which means they cannot, the length or the number of elements in this type of arrays cannot basically grow or shrink at runtime. These are fixed size as soon as you declare them and basically create one of these using the new operator. This, you have to specify the size, and then that's fixed and that can never change, right? The preceding program declares an array named an array with the following line of code. So this is just declaration. We haven't defined it yet, which means we haven't told the compiler how many elements. And so basically here we just tell the compiler that a reference with the name an array exists, right? But we haven't told the compiler this reference to points to what size of array, right? So we haven't used the new keyword to actually tell the compiler to allocate memory that this reference or pointer points to. Like declaration of variables of other types, an array declaration has two components: the array's type and the array's name, right? So we said that in Java we put the square bracket right after the type, and this whole the name plus square brackets mean it's one type, array type, right? And it defines an object type. We said that in C or C++, we put the basically a square brackets after the name of the variable, something like this. So if we want to define the int array, which is a1 in C, C++, a1 is a pointer pointing to the first element. In Java, a1 is a reference that's referring the basically the first element. And we said that the meaning of a1 being a pointer to the first element is that in C, C++, the square bracket is an operator that is overloaded for pointer types in the way that when you say a1 square bracket some index n, the compiler after the compilation, what is written in assembly is basically a1, which is the pointer, the address, plus n. And the compiler looks at the type and basically knows that if we add n to a pointer, we have to navigate the memory n times the size, right? Size of the type of the variable that this pointer pointing to, because pointers in C or C++ have a type. Here it's int, right? So the compiler writes this, and then if we want to read or write, let's say we want to read this element a1 and n. So what compiler actually writes in assembly code, basically the instruction to the CPU is take the address where a1 is pointing to, navigate through that memory address, because we know that the static arrays or built-in array types are a contiguous block of memory. That's a guarantee that both C++ language and the Java language provide, right? These are very low-level constructs, memory constructs, a group of memory. So basically what compiler writes in the assembly code is something like this. Take the address here, offset by n times size of int. Let's say this is 4 bytes, so n times 4 byte, right? And then dereference it. So it tells the compiler to actually read the value. Dereferencing means read the value that is in that memory address. So this whole thing gives the memory address that we are interested in, and dereference means read that. Obviously, the dereferencing operator is hidden in Java. That's why we say this is a reference. And in Java, the same story happens, but we don't have access to this size of operator, and a1 is really, we cannot do something like treat it like a memory address. It's more like a reference. So in Java, in C or C++, there are two ways. Either we say a index n, and the compiler, because the index or a square bracket operator is automatically overloaded, or we can directly use this notation, pointer notation, dereference a1 plus n. So in the source code of C, C++, when we say A1 plus N, the compiler actually translates this into N times size of the type that the array holds. So this is just a syntactic sugar for us in the source code to easily work with arrays and addresses, and this holds true for any basically pointer type. A1 is a pointer type to int here in this case. And then let's say if we want to say A1 equals 3, in Java we only have the option to write it this way. In C or C++ we can either do this or say A1 plus N dereference equals 3. And because eventually this square bracket notation will translate into this, and this will translate into N times size of int, right, size of the type, and this is written in the assembly code. So Java hides the low-level pointer stuff just because it's easier to deal with, and then we don't have multiple ways of dealing with these built-in array types. Because you look at the source code of C, C++, some people maybe prefer pointer notation, some people prefer index notation, and if you try to mix them together, it makes reading the source code more difficult. So Java just says, okay, there is only one way, only using the index notation, right? So the arrays type and the arrays name, these are two things that we use to declare an array. And again, array, this int here is the primitive type, the type of each element. It could be a primitive type or an object type. For example, a string array. A string is an object, is a class, not a primitive. And arrays type is written as type, a square bracket, right? Where type is the data type of the contained elements. The brackets are special symbols indicating that this variable holds an array. And again, you can never subclass an array type because these are built-in types into the JVM itself, right? There is no class definition associated with an array type. The size of an array is not part of its type, which is why the brackets are empty, right? And we use the bracket operator when we define the array, basically called the new operator. The size of array is not part of its type, which is why the brackets are empty. And array's name can be anything you want, provided that it follows the rules and conventions as discussed in the classes section. So basically the name of the array that you define is the same, follows the same rules and conventions as the ones we discussed for naming variables, for example. As with variables of other types, the declaration does not actually create an array. So when you declare something, you're not allocating memory, right? Allocation memory happens when you actually define it. Here we're just declaring it, telling the compiler that, hey, from this point on, whenever you see the name of this name variable, an array, it means it should be a reference to an int array. That's just what it means when we declare it. We haven't called the new operator, we haven't created an actual array, we haven't allocated the actual memory values, right? Memory area or memory space for this array. Okay, it simply tells the compiler that this variable will hold an array of a special type. Now it doesn't hold anything, it's pointing to, it's a pointer or a reference. It's referring to some memory area, and in terms of built-in arrays, the variable or the pointer points to the first element, right? It doesn't hold anything. I mean, when you deal with a primitive variable, yes, the variable is still a pointer, but it points to that memory location that holds the value, right? Same with arrays. This array points to the first element of the array, right? Will hold an array of the specific type. Similarly, you can declare arrays of other types. So these are all primitive types: byte array, short array, long, float, double, boolean, char, and a string. And note that a string is not primitive. So you can say type and a square bracket. This type can be a class type, an object type, or a primitive type. And then you can also place the brackets after the array's name. So float, array, a square bracket. Now let's quickly try this. So let's say int a2 array. And this also works. And we can do a sysout, let's say new int 4, and then a2 dot length 4, right? So in C or C++, we put the square brackets after the name of the variable. In Java, we have both notations, right? So let me just maybe So then the question is, so we can declare this like this. So declaring an array also like this. We put the square brackets, declaring an array, right? This is this is the preferred notation. So the preferred notation is put the square bracket basically next to a type, which makes more sense, right? And then this is the second way. Now obviously the Java wanted to be close or very similar in the syntax or in the source code to C++. That's why they also kept this. But in reality, the problem with this is it's not immediately clear that this A2 is an object, because we know that int array is an object, right? And in the bytecode, the type, the notation is a square bracket, which defines an array, and I. This is a primitive array type, right? So I discourage using this kind of notation. So this is the second way, and discouraged, because it's a little bit ambiguous, that it's not immediately clear that you can also put a space here, that's fine. You can also put a space here, that's fine. The compiler, these spaces are invisible to the compiler, but it's better to don't put any space here. The reason again is that int array can quickly tell us that it's a type of int array, right? But here, if you look at it, okay, it's int A2, and then you look at the square bracket, okay, this is actually int array, right? And obviously we are we shouldn't redeclare a variable. This works fine, right? All right, so you can put the square bracket in between the type and the name, or after the name. I highly recommend that stick the square brackets right after the type. However, convention discourages this form. The brackets identify an array type and should appear with the type designation, which means the second way of declaring an array in Java is discouraged, right? You shouldn't do that. The convention is this one, int array or any type array. That's easier to understand. This one, the second one, is just because it's very similar to C or C++. All right. So one thing that I want to point out about arrays, and later on we look at the so any array type array, right? We declare an array type, primitive or object, class type A equals, for example, new type and some number of elements, right? So let's call this M, number of elements. Now the thing here is that we said that when we use a local variable, we can declare it as final, and this A, although it's referring an array, it's still a local variable. So let's say int A3, int array A3 equals new int before that, let's also talk about initialization. So direct initialization. So you can use equal, which means we are declaring the variable and directly assigning it using the curly brackets, right? So 1 2 4 3 5 minus 10, and the compiler is able to automatically deduce the fact that, okay, so you want this A3 to be of type int array, and it holds the value 1 2 4, these 6 values. So if I do a sysout on the length, you see that it will give me 6. Yes, right? And you can initialize one-dimensional arrays or arrays with more than one dimension, which is the topic of our next lecture. But here the compiler was able to deduce that. Now let's obviously, if I remove this and run this, now the compiler deduced that you want an array with actually 5 elements. Let's say we want an array with 6 elements, but we only want to initialize the first 5 elements, right? How do we do that? One way would be something like this. So I'm going to put back this minus 10 here, but here I'm going to say, but if obviously if I keep this notation, then the problem here is that this A4 is, the compiler assumes that it's what you want is an array with 5 elements, but we can explicit size at initialization. So we can explicitly tell the compiler that I want an int array which has 6 elements, but I only initialize the first 5, and we know that these so what happens then? So then we have to directly use the new operator and then this is 6, and then so it says cannot define dimension expression when an array initializer is provided. So this notation may not work. That's just because the Java decided not to allow that. So if you say 6, then you have to provide 6 elements. So if you don't provide the dimension, the compiler will deduce that it's still 5. So you still can use the new operator, and but then if you specify the size here, then the compiler says the size of the initializer list doesn't match this dimension, right? So then you have to kind of write a for loop or something of that sort to initialize your elements. Now the other thing is that you can from a method you can directly create an anonymous array, an array that doesn't have a name. So let's see, public static, let's say int array, get array, int dimension, right? And then or maybe just let's just return a fixed size, and you can directly say new int array, and you can directly initialize it with initializer list 1 2 minus 4. So this works. We're creating an anonymous array, an array that doesn't have a reference or a pointer associated with it, but then we are returning a reference to it. So we can say int or var. Let's see if var works with array types, get array. So var works. So again, var works for any type of local variable, even array types. So a5.length. So we are directly returning a primitive array, and it doesn't have a reference to it. We didn't define a variable that points to this, but that's fine. We directly initialize it, and the compiler infers that you want 3 elements. That's fine. And then if we look at the length of a5, it's 3. So this works. We can also use var, for example, here also, because for a4 there is we already used the new. What about here? If we don't use the new operator explicitly, use an initializer list, can we use var? Let's try that. And no, this doesn't work. Array initializer, and array initializer needs an explicit target type. So if you don't use if you don't explicitly use the new operator with the type of the array, the var gets confused because it doesn't know what the type is, right? Now the interesting thing is that it could in fact deduce the type here, but Java decided not to allow that, because you can mix these, right? 2.1, and it's not clear what's going on. Do you want everything to be double, or do you want everything to be int? So it's not clear. So it's not safe or clear to just rely on the initializer list, because the user might put different types of values like integer, float, or something here. So you have to, in this case, explicitly type it, and then if you mix the types in the initializer list, the compiler is going to complain. It actually tells you which element it's complaining, which is very nice and intelligent thing to have, right? Cannot convert from double to int. If we say byte, for example, this works because byte can be promoted to int. But the nice thing here is that the compiler can tell you explicitly which element type is not compatible. 3f, for example, which is very nice feature to have. All right. So if you use initializer list, you cannot use var. If you want to use initializer list but use var, then you have to explicitly use a new operator with the type, so that you tell the compiler, you give it extra information on what's going on, right? All right. So this was our continuing basically discussion on the arrays. I hope you enjoyed this. Please stay tuned, and I'll see you in the next one.